Tonight, the night sky holds a secret. A faint, ghostly light has appeared near the edge of our solar system, and it's moving fast. For weeks now, telescopes across the world have locked onto that one mysterious point, tracking every flicker, every pulse. At first, it seemed ordinary, another icy wanderer drifting through the void. But as the data came in, something didn't add up. Its brightness, its orbit, its composition. Nothing behaved the way a comet should. This is Comet R2 Swan, a frozen relic older than the sun itself. And right now, it's racing toward the light, toward the very heart of our solar system, before vanishing behind the glare of the sun. Soon, it'll be gone, hidden for years, maybe forever. But before that happens, we have one last chance to ask, what is this thing? And where did it come from? It began quietly. On a September night in 2024, a faint moving point appeared on images from the Solar and Heliospheric Observatory, a decades-old satellite orbiting between Earth and the Sun. The detection came from one of its least glamorous instruments, a camera built to monitor the solar wind, known as SWAN, Solar Wind Anisotropes. The team who first noticed it almost dismissed it as noise, a simple cosmic ray hit on the sensor. But then, image after image, night after night, the same moving speck returned, shifting ever so slightly, each time a little brighter. When the data was confirmed by ground-based observatories in Australia and Chile, it was officially catalogued as Comet R2 Swan. At first, astronomers believed it was just another long-period comet, the kind that drifts inward from the Oort cloud once every few thousand years. But within weeks, R2 Swan began to surprise them. Its brightness increased far too quickly for an object still so far from the sun. By the end of October, it was glowing 10 times brighter than models predicted, a sudden, inexplicable surge of light that left even the veterans at the European Space Agency speechless. That was the first red flag. When the first orbital calculations were published, something immediately stood out. R2 Swan was moving too fast. Its trajectory wasn't the neat, looping ellipse expected of a typical comet bound by the sun's gravity. Instead, it traced a hyperbolic path, the unmistakable signature of an interstellar visitor. In simpler terms, it was just passing through. It would come close, swing around the sun once, and then disappear back into the dark, never to return. The comet's inclination was strange too. Instead of following the familiar, flat plane where most planets orbit, R2 Swan cut across the solar system at an angle of more than 50 degrees, slicing through the planetary paths like a rogue outsider. Astronomers noticed that its incoming vector didn't align with the normal flow of long-period comets from the Oort cloud. It was coming from somewhere else entirely. And the speed, that was the part that made even seasoned researchers pause. At its current pace, R2 Swan was moving faster than 45 kilometers per second, faster than any natural cometary body that had been recorded at that distance from the sun. Too fast to be captured, too fast to belong. If it truly came from beyond our solar system, then this was only the fourth interstellar object ever found, after Oumuamua, Borisov, and 3I Atlas. But even among that tiny exclusive list, R2 Swan didn't fit neatly into any category. Because while the others were fading as they approached the inner system, this one was growing brighter, more active, almost aware of the sun's pull. And so, the question grew louder. If it's not from here, then whose comet is it? Even before R2 Swan crossed the orbit of Jupiter, telescopes began noticing something that didn't make sense. It was glowing, far too much for a comet still that far from the sun. Normally, comets remain dark and inert until sunlight heats their icy surfaces enough to trigger sublimation, the process where solid ice transforms directly into gas. That's what creates a comet's halo, or coma, and later, its long luminous tail. But that only happens when the object is well inside the orbit of Jupiter, close enough for solar radiation to do its work. R2 Swan, however, broke that rule. When it was still nearly 1 billion kilometers from the sun, out past the orbit of Saturn, its coma was already visible, expanding rapidly, glowing brighter by the day. By the time the European Southern Observatory turned its massive VLT array toward it, the coma had grown to nearly 200,000 kilometers across, a shimmering sphere of ionized gas surrounding a nucleus no larger than a small city. Scientists at NASA's Goddard Space Flight Center began analyzing the light signature, expecting to find traces of water vapor, the hallmark of an ordinary comet. But the results stunned them. Almost no water. Instead, the spectrum was dominated by carbon compounds, carbon dioxide and carbon monoxide, erupting violently from the surface. It shouldn't have been possible. The temperatures out there were far too low to trigger CO2 activity naturally, and yet R2 Swan was venting massive amounts of gas, as if something deep inside it was releasing stored energy. Some compared it to a pressure valve opening. Others, more boldly, said it looked like a machine powering up. As the coma grew and brightened, one astronomer described it perfectly in a late-night interview. "It's behaving like it's alive. Either it's made of something we've never seen before, or it's doing something we don't yet understand." The deeper scientists looked, the stranger comet R2 Swan became. When the James Webb Space Telescope turned its infrared eyes toward the object, it captured one of the most detailed spectra ever recorded from a comet that far away. And what it revealed forced researchers to question everything they thought they knew about how comets form. The data showed an astonishing imbalance in chemistry. R2 Swan's coma wasn't just rich in carbon monoxide, it was dominated by it. The CO2-H2O ratio was measured at nearly 20-1, meaning there was 20 times more carbon monoxide than water vapor. For context, most solar system comets barely reach a ratio of 2-1. That alone would make it unique. But the Webb data also showed faint metallic lines, traces of nickel ions, shimmering in the spectra like fingerprints of an unknown origin. And yet, there was no sign of iron, its natural cosmic twin. In every star, asteroid, and planet humans have ever studied, iron and nickel come together, born side by side in the hearts of dying stars. Seeing one without the other simply doesn't happen, unless it was separated intentionally. The European Very Large Telescope in Chile confirmed the finding weeks later. Nickel, but no iron, high carbon, low water. The ratios were all wrong. It was, by every metric, alien. Not in the science fiction sense, but literally foreign to the chemistry of our solar system. Some proposed it formed in a distant star system where carbon and volatile gases dominated, a cold realm where metals condensed differently. But others whispered a more provocative thought. If iron and nickel were somehow refined apart, could this be debris from something that was once built? No one could say, not yet. But one thing was certain. This was not a comet like any we had ever seen before. Then came the moment when R2 Swan broke every rule in the book. By late November, its coma had grown so vast that it filled the frame of the solar orbiter's wide-angle cameras. The tail, that brilliant streaming veil of ionized dust, was supposed to stretch away from the sun, shaped by the steady push of the solar wind. That's cometary physics 101. But R2 Swan's tail didn't obey. At times, it seemed to flick and twist, then swing toward the sun, as if gravity and radiation pressure were being reversed. ESA's tracking stations confirmed it wasn't an optical illusion. Instruments aboard Solar Orbiter measured brief pulses of charged particles streaming outward from the comet itself, creating magnetic ripples strong enough to push against the incoming solar wind. That had never been observed before. Some scientists suggested that this might be the result of ion jets erupting from the nucleus, firing in rhythmic bursts that altered the plasma flow. Others proposed that R2 Swan could be surrounded by a magnetized sheath, an envelope of plasma capable of momentarily reshaping its own tail. But the data carried an even stranger clue. Hidden within the comet's emissions were faint, repeating radio spikes, evenly spaced, almost rhythmic, like a heartbeat in static. For days, observatories debated whether it was just interference. But the pattern persisted, detected by multiple stations at intervals too regular to ignore. A scientist at NASA's Deep Space Network described it quietly in a press note that was later deleted. "We might be looking at an object that doesn't just reflect solar energy, it might be generating it." No one wanted to say it aloud, but the implication was clear. R2 Swan wasn't just reacting to the sun, it was responding. It didn't take long before someone noticed the pattern. When researchers at the Harvard-Smithsonian Center for Astrophysics overlaid R2-SWAN's inbound trajectory with that of the interstellar object 3I Atlas, a strange symmetry appeared. Both objects had entered the solar system from opposite sides of the galactic plane, mirror paths, nearly aligned in inclination, yet moving in opposite directions, like two messengers crossing the same invisible line, years apart. Even stranger, both shared the same chemical fingerprints, carbon dioxide dominating water by extraordinary ratios, and traces of metallic nickel without iron. The odds of that happening by coincidence were beyond slim. A quiet study circulated within ESA's internal research board, suggesting that R2-SWAN and 3I Atlas might originate from the same stellar nursery, a region of the Milky Way twice as old as our Sun, where volatile-rich comets could form in colder, denser clouds. But one of the researchers, speaking off record, used different words. It's as if they were fragments of the same parent body, one that broke apart a very long time ago. Others began to wonder whether these weren't just natural fragments at all. A number of amateur astronomers noted that the timing between the two arrivals, just over a year, seemed almost deliberate. Both entered the solar system on intersecting planes, both displayed anomalies, and both appeared to be communicating through their strange emissions. It was a fragile theory, built on speculation and pattern seeking. But the alignment was there, and the behavior was real. As one astrophysicist wrote in a late-night post, if 3I Atlas was the first signal, then maybe R2-SWAN is the reply. And suddenly the mystery didn't feel isolated anymore. It felt coordinated. By December, the story of R2-SWAN had spread far beyond the astronomy community. Every major observatory on Earth was locked onto it. But now, NASA, ESA, and even JAXA were quietly coordinating their instruments for something bigger, a full-scale observation campaign. At NASA's Jet Propulsion Laboratory, mission planners began cross-referencing orbital models, trying to determine whether any existing spacecraft could intercept or image the comet up close. Parker Solar Probe, already diving perilously close to the Sun, was ordered to monitor plasma fields as R2-SWAN approached perihelion. Solar Orbiter, operated by ESA, adjusted its trajectory slightly to align its high-gain antennas toward the comet's path. This wasn't routine. It was rare, almost unheard of, for so many agencies to cooperate on a non-scheduled target. The timing was critical. By November of 2025, R2-SWAN would reach its perihelion, sweeping within the orbit of Mercury, closer to the Sun than any interstellar object ever observed. If it survived that encounter, it would sling back out toward deep space, accelerating beyond detection range by early spring. That narrow window meant everything. For the James Webb team, it was a race against brightness. The comet's growing coma was now so intense that it risked overloading Webb's sensors. The SOHO and STEREO satellites were tasked with continuous imaging, while ground telescopes at Mauna Kea and Paranal tracked fluctuations in luminosity every 6 hours. Behind the scenes, internal memos described the mission as our last clear look before the Sun erases it. But there was also fear. If R2-SWAN's volatile carbon-rich core became unstable near perihelion, it could detonate, vaporizing completely, like Comet ISON did in 2013. Still, some scientists dared to hope it would hold together, because if it did, if it survived that fiery pass, humanity might finally glimpse the true structure of its nucleus, and perhaps the truth about where it came from. If it survives the Sun, one NASA scientist said quietly, we might finally see what it's truly made of. With every new image, every new reading, the theories multiplied. Some were careful, grounded in physics. Others reached deep into the realm of imagination. The most conservative interpretation suggested that R2-SWAN came from an ancient planetary system far older than our own, a cold, carbon-dominated region of the Milky Way, where volatile gases froze into strange crystalline forms. In that environment, carbon monoxide and nickel could bind in ways never seen here, producing a comet that looked alien simply because it was built under alien conditions. But others weren't satisfied with that explanation. A few independent researchers noted the repeating radio pulses, those faint rhythmic spikes in the data, and proposed a more radical idea. that R2 Swan might not be a natural object at all. What if it was a derelict probe, a relic from a civilization so ancient that its creators were gone before Earth even formed? What if the nickel-rich, iron-poor shell wasn't geological, but engineered, a corrosion-resistant alloy meant to survive interstellar flight? The notion was dismissed by most scientists, yet it lingered in every forum, every headline. Some pointed out that the pulse interval corresponded almost perfectly to the comet's rotational period, as if the signals were synchronized with its spin. Others noticed that the emissions intensified whenever it crossed the heliospheric current sheet, a vast magnetic plane connecting the sun's poles, as though responding to something. Still, there were stranger ideas. One physicist from Kyoto University half-jokingly referred to R2 Swan as a living comet, an organic entity metabolizing light and dust, exhaling carbon dioxide as a byproduct. The statement went viral before he could retract it, and while most agreed that such notions stretch science beyond reason, no one could completely dismiss them, because so far, no one had an answer that fit every observation. "We don't know what it is," an ESA spokesperson finally admitted, "but we know it's not acting like anything we've ever seen before." And with each passing day, as it drew closer to the sun, the comet seemed to guard its secrets more tightly. No one could say what would happen when it reached perihelion. Would it disintegrate? Would it flare even brighter? Or would it reveal something no one on Earth was prepared to see? Now, the countdown begins. As Comet R2 Swan races toward the sun, its brilliant coma grows wider each night. Its tail flickers like a torch against the black of space. But soon, that light will vanish into the glare of daylight, lost behind the solar disk, hidden from every telescope on Earth. For astronomers, this is the hardest moment, to watch a mystery drift beyond reach. Because once R2 Swan disappears behind the sun, no one knows what will happen next. It may survive the inferno and emerge renewed, brighter than before, or it may never return at all, breaking apart into invisible dust, taking its answers with it. Every comet carries a story, of ice, of time, of distance. But this one feels different. Its chemistry doesn't match anything from our cosmic neighborhood. Its orbit cuts across the solar system like a scar, sharp and deliberate. Its light pulses as if it remembers something we don't. And somewhere, beyond the sun's blinding edge, that story continues, unseen, unmeasured, but not forgotten. When it reappears, if it reappears, our world will be watching. Because whether R2 Swan is a relic of an ancient star, a fragment of something artificial, or simply a piece of the universe playing tricks on our understanding, one truth remains. We are witnessing the unknown, and that's what makes it beautiful. It came from the darkness, one scientist said, watching the final telemetry fade. And maybe that's where it belongs. As the light fades from our skies, one question lingers quietly in the silence. Was Comet R2 Swan just another frozen wanderer, or something that was never meant to be found,